Hi guys, trust you're doing fantastic. In today's video, I'm going to be teaching you how to convert octal number system to hexadecimal number system. In the last video, we looked at the conversion of hexadecimal to octal number system. So in this video, we're going to be looking into the conversion from octal number system to hexadecimal number system. So let's go straight into today's task. Now let's consider the example. It says 72.1 base 8 equal to x base 16. It says find x. Now remember the rule. The rule is that there are no straightforward method to just convert base 16 to base 8 or base 8 to base 16. So all we need to do, we need to follow the laydown method, which is to convert first to binary and then from binary to base 16, just like we did in our previous video where we considered hexadecimal to octal conversion. Now the first thing we need to do is to convert this base 8 to binary. Now to convert base 8 to binary, the relationship is 3 bits because the maximum number of bits required to represent octal number system in binary is 3 bits. So we're going to use this simple cheat code, say 421. All right, so we'll never forget this. So let's represent this using the simple table, the table that we know about. So 7 is going to give us 1, 1, 1. 2 is going to give us 0, 1, 0 points. 1 is going to give us 0, 0, 1. And so the next thing we need to do is to convert binary to hexadecimal. Now to convert binary to hexadecimal, what is the relationship? Now the relationship is that 4 bits is required to represent hexadecimal number system in binary. So we're going to use the cheat code 8421. And so we want to represent this in hexadecimal. So for we to do this, we have to follow some principles, which is we have to introduce what we call grouping and padding. Since this is a 4-bit representation, so we have to group in bit of 4s. So we have to group in 4s. So now the rule says when we do grouping, we have to group the digit before the decimal point to the direction of the left. So when we're grouping digit before the decimal point, we have to do that to the direction of the left, and we also need to apply padding in the same direction to the left. So let's begin the padding and the grouping. So we're going to group and then we pad for situation where we don't have a complete group. So we're going to have 1, 2, 3, 4. So we're going to group this first 4. Okay, we group to the left. So now we have 2 digits left. So it means we need to pad with 0. Okay, we add 2 more zeros so that we can have 4 digits and then we have a complete group. Right now let's group the digit after the decimal point. So we have to group to the right. So in this case we have only 3 digits. We need to pad with 0, 1 more 0 so that we can have 4 digits and then we can group accurately to the right. Now we need to get what is the equivalent of these binaries in hexadecimal. Now since we know that the code is 8421, all we need to do is that for this we're going to get 8421 is going to give us 3 using this code 8431. Now if we check the code for 1010, so that is going to give us 10, right? So we'll have 10 at this point, which is 8 and 2. Then we'll have points 0010. It's going to give us 2. All right, so remember, since this is an hexadecimal number system, it means the value 10 will be represented by a. So therefore what we'll have is going to be 3a.2 base 16. So this will be the final answer. This is very simple. This is very straightforward. So at this point, I'm going to draw the curtain for today's lecture. Pay attention to the subsequent videos in this channel. All right then, enjoy this video. Bye.